Let us start with the introduction to data structures. Data is an integral part of our applications or programs. If I define a program is nothing but a set of instructions which perform operations on data to get some results. So without data, there is no need of instruction, no use of instructions. Then the data term data, we use it at many places like data structures, databases, data warehouse, big data. So from this, what is actually data structure? So for this, if we have the little bit knowledge about all other things also, that will be better. So first I'll start with data structures, and we'll also have the brief introduction to databases and data warehouse as well as big data. So first let us start with introduction to data structures. First of all, let me introduce what is data structure. Data structure can be defined as arrangement of collection of data items so that they can be utilized efficiently. Operations on that data can be done efficiently. So it's all about the arrangement of data and the operations on the data that are efficient operations on the data. But the question is where? Inside the main memory during the execution of a program. So without data structure, there cannot be any application. Every application will have set of instructions which will perform operations on data. So data is mandatory. Then where the data is kept? Inside the main memory. Where the programs will be? Inside the main memory. Right? So during the execution of a program, how the program will manage data inside the main memory and perform the operations, that is data structure. So I'll take an example and explain you in detail how the program utilizes data and how they put the data inside the main memory. Let us look at this diagram. Here is the CPU processor, that is central processing unit, that is our microprocessor, and this is main memory. Let us say this is RAM, and this is a storage, that is hard disk drive or external storage, or just we call it as storage. This will execute our programs, that is, it is a processor, it will execute the instructions. And this is temporary memory, that is working memory. It is also called as primary memory. And this is permanent storage. This is permanent storage. So if we look into our PC, then we will have a processor, RAM and hard disk. Or if we look into a mobile phone, then there will be a processor and there will be some RAM like 2 GB or 3 GB or 4 GB of RAM, and there is a storage of 16 GB, 32 GB or 128 GB like this. Then where do we keep our programs? When we install any program in our PC or on our mobile phone, a program or an application will get installed on storage. So here I am showing it as a program file. This is a program file. Then where do we keep our data? That also we keep it on hard disk. Suppose you have any pics or photos or videos or any documents, that all you keep it in your hard disk, or in your mobile phone you keep it in a storage. So these are data files. So I'll take one example of a commonly used application like MS Word. Most Windows users use MS Word, commonly used software, or Notepad also you can take. Assume that this is MS Word program file and this is document file or docx file, and this is MS Word file. Now through this example, I'll explain you where the data structure comes into picture and how MS Word may need data structure. Now let us see how our application program runs. If you want to run MS Word on your PC or your mobile phone, you are touching an icon or double clicking an icon of MS Word, then let us see what all happens. This MS Word program will be brought into the main memory. So it is brought into the main memory. So let us say these are all the instructions of MS Word program. Such as I am showing lines to show the machine language code or instructions of MS Word program. So whenever you want to run an application, the application code or the program code has to be brought into the main memory. Then once it is brought in, CPU will start executing this MS Word application. So you will see a window appearing on the screen, and then all the menu options, everything comes up and you can start using MS Word. Now, if you want to open a file, document file in your MS Word application. Suppose this program wants to access this data in this file, then this data also has to be brought into the main memory. So let us say this is data, or this is some Word document file. So data is also brought into the main memory. Now from this I can explain that, I can say that a program has to be brought into the main memory for its execution, as well as data has to be brought into the main memory for processing on the data, so that these instructions can perform operation on the data. Program cannot directly process the data keeping it on the storage. The data has to be brought into the main memory. Now from this we can say that every application deals with some data, whether it is MS Word, or if it is Notepad, then the Notepad file, text file has to be brought into the main memory. If it is a Chrome, you are browsing any web page, then that web page, when it is coming from internet, it has to be in the main memory. So every application on your computer system or your mobile phone deals with some data, and that data has to be inside main memory. How you organize the data inside the main memory such that it can be easily used by this application, efficiently utilized by this application program. So how you organize the data? So the arrangement or organizing of the data inside the main memory for efficient utilization by the application, that arrangement is called as data structure. So data structures are formed in the main memory during the execution time of a program. When the program runs, it needs data. So the question, how it will arrange the data in the main memory for performing its operations. So that arrangement is called as data structures. So data structure is a part of running program. You may be knowing different data structures like arrays or linked lists or trees or hash table. Whatever the data structure is suitable, an application can use that particular data structure here for arranging its data. Data may be a text data or multimedia data like images or videos. A lot of contents may be there in the form of data. So all those contents, how they are organized in the main memory. So we have to design some data structure so that the application can use it perfectly or more efficiently. An application should work faster or process faster over the data. So that's it. So I have given you the idea what is data structure and where it will be in your computer system. So it is not on the disk, it is inside the main memory. So without data structure, we cannot develop any application. Now let me give you some idea about databases. See, when the data is larger in size, or commercial data that is used in businesses like banks or retail stores or manufacturing firms, they will have a lot of data and they will have some organized data in the form of database tables or relational data. And where they keep that relational data, all that data is stored on the disk. So I'll just remove this and show you a relational table that is kept on the disk. Now you can see here that on the disk, on the hard disk, this is a table, database table. I am showing only one table. There may be many tables. Data may be spread across various database tables and it is organized in the form of tables, and the tables are having relationship between them. So mostly commercial data is stored in the form of database tables. Now, if any application program is using that database, then data has to be brought into the main memory, then only it can use it. So again, you need data structure here. When you are pulling the data from the hard disk or from the storage to the main memory during execution, then you need definitely data structure here. So arrangement of data here in the main memory is data structure. Then how this data is organized in the form of table on the disk, this is database. This is database. Just brief introduction I am giving you. Database means arranging the data in some model, like say relational model, in the permanent storage so that it can be retrieved or accessed by applications easily. That arrangement in the hard disk or in the permanent storage is called as database. Then next, let us go to the next term. Like I was talking about commercial data. that is data used in businesses. So they will have huge amount of data daily coming in, like many customers are making transactions or a lot of goods are manufactured and sold. So the data size will be growing day by day, large and large. So large size data are very large data that may not be used daily, right? Like 1-year-old data or 10-year-old data that may not be used now. So commercial data can be categorized into two, that is operational data or legacy data, old data. Operational data that is used, that is daily, and legacy data can be kept as storage somewhere. If required, we can fetch that data and use it. Or you can say historical data. So that historical data can be kept on array of disk, because just imagine 10 years of data or 50 years of data is kept on not just one disk, array of disk. So the large size data which is kept here, that is acting as a historical data for any commercial firm. This is data warehouse. This is data warehouse. So mostly commercial firms will have their data warehouses. That data warehouse is helpful for analyzing the business or making the policies or starting a new trend or giving offers to the customers, dealing with the customers. So that previous data, old data, will help organization in taking decisions. So this large size data is data warehouse, and the algorithms written for analyzing that data are data mining algorithms. Data mining algorithms. All right. So wherever data is used, I'm explaining about that. See, this is database, right? Database. This is data structure. So data structure inside the main memory during the execution. Database on the disk, large size data, and the huge size data which is inactive now, and when required it is utilized, that is data warehouse. And the last term, that is big data, is the term used nowadays. Big data. With the start of internet, a huge size data is accumulating day by day in internet. That data is about things, about people, about places. A lot of data is available in internet, and by analyzing that data we can take a lot of decisions, that is for management, for governance, or for businesses. Analysis is very useful about that data. Storing and utilizing that very large size data, that study is big data. That study is big data. Now, for a beginner, these are maybe confusing terms, so I have separately defined them where each is used. Again, I repeat, data structure is in main memory during the execution of a program. Arrangement of data here. And arrangement of data on the disk is database. Arrangement of data in the array of disk as data warehouse. That is not operational, that is not used day to day. And big data, that is used in internet. So that's all. I have given you the different places where data is used. Now our subject is data structures. So let us start with data structures in next video onwards. In this video, we will learn about static and dynamic memory allocation. So these are the topics that I'm going to cover in this video. I'll discuss about the memory, how the memory is utilized, how it looks like. Then we will see how a program uses the main memory, how the program will utilize that main memory. Then we'll see static memory allocation, that is static allocation, or dynamic memory allocation. So these are the topics we'll discuss. Let us start by studying something about main memory. Let us discuss static versus dynamic memory allocation. So for that, we should understand memory. Suppose this block shows a memory. This is a memory. So the memory is divided into smaller addressable unit, that is called as byte. So memory is divided into bytes. So these boxes, these check boxes, let us assume those are bytes. And this is the entire memory. A small picture I have taken. Every byte is having its address. Let us say the address of this is 0, and this is 1, this is 2, 3, 4, 5. And this will be 6 and 7, 8, 9, 10, 11 and 12, 13 goes on. So I'm starting from the bottom. One thing to observe is that diagram I have drawn as a two-dimensional, but the addresses are single-dimension addresses, linear addresses. So address will have just one value, not like a coordinate system, x comma y, it will have a single value. So addresses are linear. After this byte is 5, then this is 6 and 7 and so on. So it depends on the size of the memory, every byte will have its own address. So if I take a bigger size of memory, let us say this is a memory, and then this cornermost byte address is 0. So let us assume that this cornermost byte's address is 65535. So total 0 to 65535 makes 65536. So total number of bytes are 65536. This is nothing but 64 into 1024. So this is 64 kilobytes. So in my entire discussion, for the entire discussion of the subject, I'll be assuming that the size of the main memory is 64 kilobytes. Okay, let us make this assumption. The size of the memory can be anything. Nowadays we are using memory in GBs, like 4 GB, 8 GB memory we are using. But to understand, we have to take a small part of main memory. So I am taking 64 kilobytes of memory. So the first address is 0 bytes and the last address is 65535. So total 65536, that is 64 into 1024, so it is 64 kilobytes. So this main memory is of 64 kilobyte. Every byte is having its address, like how I have shown you here. In our computers, if you have larger size RAM, that is 4 GB or 8 GB, that entire memory is not used as a single unit, but it is divided. It is divided into manageable pieces that are called as segment, and usually the size of a segment will be 64 kilobyte. So I am talking about a segment. So in our discussion, always we'll assume that the size of our memory is 64 kilobyte, that is we are talking about a segment. Now next we have to understand how a program uses main memory. Now let us see how a program utilizes main memory. This picture shows this block, entire block from this corner to this corner is a main memory. Assume that this byte address is 0 and this cornermost byte address is 65535. As I said, we'll be taking one segment of memory and studying it. So this entire main memory is divided into 3 sections and used by a program. So I'll label the sections. One of the section where the program resides is called as code section. And one of the section, usually this is the section, this portion is called as stack. And this remaining portion is called as heap. But I'll just change the side because it is easy for me to discuss. If I call this portion as stack and this portion as heap. So a program uses the main memory by dividing into 3 sections, code section and the stack and the heap. I am showing stack at this place. Now I'll explain how a program uses these 3 sections. So let us see. See here I have a program file on the hard disk. If I want to run this program, so this program, the machine code of the program first should be brought inside the main memory. So it is brought inside the code section. So let us say this is a program or the machine code of a program. So the area that is occupied by the program in the main memory, that section is called as code section. That may not be fixed, it depends on the size of a program. So this is the code section area where the machine code of a program is loaded. Now once it is loaded, the CPU will start executing the program, and this program will utilize the remaining memory as divided into stack and heap. Now let us learn how this stack and heap works. So I will take the example code and I will show you how stack memory is used and how heap memory is used. I have taken an example code here. See, this is my main function. It's having 2 variables. One is of type integer, the other one is of type float. Now I will assume here, listen carefully, I am assuming here that integer takes 2 bytes and float takes 4 bytes. In C++ programming, Number of bytes taken by integer depends on the compiler and the operating system and the hardware. It depends on various things. So we say mostly depends on the compiler. So integer may take 4 bytes also, 2 bytes also. Okay. So 2 bytes is easy for explanation purpose. So I am taking integer as 2 bytes. If you take Turbo C, which is a 16-bit compiler, it takes 2 bytes for integer. Usually, if you use a Dev Studio or code blocks or anything, then integer will take 4 bytes in that one. So it's a 32-bit compiler. Alright. So integer can take 2 bytes also, 4 bytes also in C++. Got it? So I am assuming integer takes 2 bytes and float takes 4 bytes. Now, let us come back to the point that we were discussing. We were discussing how this heap memory and the stack memory is used by the program. So let us see. I have these two variables, 2 bytes and 4 bytes, total 6 bytes of memory. In the program, it is written that it needs 6 bytes. So that 6 bytes of memory is allocated inside the stack. Inside the stack. So let us show it as separately. So this is 2 bytes and this is 4 bytes. So these 6 bytes are given to the program, and this is nothing but a main function. I am showing only main function. So this block of memory that belongs to the main function is called as stack frame of main function, or it is also called as activation record of main function. Activation record of main function. So one thing we learned that whatever the variables you declare inside your program or inside a function, the memory for those variables will be created inside the stack. This portion is a stack. So it allocated inside the stack. So the portion of memory that is given to the function is called as activation record of that function. So how the memory is allocated inside the stack, it depends whatever the variables you have inside a function. So the size of the memory required by a function was decided at compile time only. Compiler will see that this needs some bytes and this needs some bytes, so it will beforehand decide that this function needs so much memory, and that memory is obtained once the program start executing. It is obtained inside the stack. So we say this is static memory allocation. What is the static here? How many bytes of memory is required by this function was decided at compile time. So it is static. So what is static? The size of the memory is static. When it was decided? Compile time. So when anything is done at compile time or before runtime is called as static. So this memory allocation is static. Now the next thing that we should also know that if there are sequence of function calls, then how the memory is allocated inside stack. So I'll write down a piece of code, a small sample code, then I'll show you how the memory is allocated inside the stack for sequence of function calls. Here I have a sample piece of code. This is a main function. Main function is having two variables, and then it is calling function fun1, and fun1 is having its a local variable x. Then it is calling function 2 and passing parameter x. This function 2 is taking parameter as I, then also it's having its own variable a. If following function calls are made, then how the memory is allocated for all these functions, let us look at it. First of all, when I want to run this program, the machine code of this program will be copied in code section. So I will write it like this. Function 2, this is the machine code of function 2, and assume that this is for function 1. And then this is main function. Now this is the machine code for this entire program. Now let us start executing. When the program starts executing, it will start from the main function. The moment it enters inside main function, it requires variable. So the memory for A and B will be allocated inside this area or this section, and that is A and B. So I'm making it as a single block. These are the two variables. Now next, main function calls function fun1. Now the control goes to function fun1. The moment control goes here, inside this, the first thing is variable is required. Variable declaration is there. So the variable is created inside the stack for this function fun1, that is x. So this piece of memory belongs to main function, and above that, this belongs to function fun1. Right now, which function is executing? Currently function fun1 is executing because we have called from here. So this topmost activation record belongs to which function? Currently executing function, that is fun1. Then fun1 will call fun2. So again the control goes to function 2. Then that is having two variables. One is its parameter, other one is its local variable. So memory is allocated for those variables I and a, and this is for function 2. Now presently function 2 is running and the topmost activation record inside this area is fun2. So currently executing function will access the topmost activation record. Now one thing you can observe that we started from main function. It has not yet finished, but it has called function 1. So main function activation record is as it is inside the stack. Then activation record for fun1 is created, means memory for fun1 is allocated. Then it is still running, but it has called fun2. So the activation record for fun2 is created and activation record of fun1 is still there in the memory. Now let us continue over execution. Fun2 is the currently executing function. Now when the function 2 has finished, terminated, then control goes back to function 1. It will come back after this point, it will come back to function 1. Inside this function 1, that is after this line, it will come to this line. Suppose there is a statement here, so it will come to this statement. What happens to the activation record of that function 2? This will be deleted. Then this, after this function 1 has finished executing this statement, it will come back to the main function after this call function 1. Let us say there is some statement, it will come to that statement. And once the function fun1 ends, its activation record is also removed from the main memory, that is from the stack. Then main function also ends, so its activation record is also deleted from main memory. So now you can see that how the activation records for sequence of function calls were created. First main function, then above that function 1 and above that function 2. Right now function 2 is running, these are already there in the memory. When function 2 ends, it will delete and come back here. When it ends, delete and come back here. When it ends, delete and the program ends. So the way activation records are created like this and then deleted like this. So this mechanism is stack, right? Top and top and top, then delete, delete. So this mechanism is stack. So that's why this section of memory behaves like a stack during the function call. So that's why it is named as stack. So that's all. This is how the main memory is used, or stack memory is used for function calls. Now one important thing to observe. How much memory is required by a function depends on the number of variables and their sizes. And this is decided by compiler only. So this memory is automatically created and automatically destroyed. Programmer doesn't have to do anything for its allocation and destruction. Just programmer has to declare the variable. So the conclusion is, whatever the variables you declare in the program or whatever the parameters your functions are taking, for all of them, memory is allocated inside the stack and it is automatically created and automatically destroyed when the function ends. Now next we'll talk about heap and see how memory is dynamically allocated from heap. Now let us learn how heap memory is utilized by a program. So I have taken a main function. This is a main function, so I am showing the code here, and this memory already we have seen. Now we have to see heap. First let us understand the term heap. Heap means what? Just piling up. If the things are kept one above another or just randomly, we use the term heap. So heap is used in two cases. One, if the things are properly organized like a tower-like thing, then also it's a heap. And if it is not organized and also it's looking like a tower, then also we call it as heap. So the important point is heap word or term heap can be used for organized thing as well as unorganized thing. So here heap is the term used for unorganized memory. It's not organized. Stack memory is organized, right? We already saw how the activation records are created and deleted, but that is not organized. This is the first point. And the second point about heap is that heap memory should be treated like a resource. So I'll tell you something about the resource in applications. See, suppose a printer is a resource for your program. If your program want to use a printer, then it can request for a printer, use the printer. Once it has finished using it, it should release the printer so that the other applications can use it. Same way, heap memory should be used like a resource. When required, you take the memory. When you don't require, you release the memory. This is the practice that we must do while dealing with heap memory. So I told you 2 points. What is heap? Second thing, it should be treated as a resource. Now the third important point, program cannot directly access heap memory. It can directly access anything inside code section, anything inside stack, but it will not access heap memory. That is like a policy of a program, that it will not access heap memory. It can if it want, but it will not access heap memory. So programs cannot access heap memory directly. Then how do they access heap memory? Using pointer. So let me show you how we can get some memory inside the heap with the help of a pointer. Let us check it. First of all, for taking some memory, I have to take a pointer. Now the first question, how many bytes pointer takes? In my discussion, for making it simple, I say that pointer takes 2 bytes. Actually, the amount of memory taken by pointer depends on size of integer usually. If integer is 2 bytes, pointer is 2 bytes. Integer is 4 bytes, so pointer is 4 bytes. So let us assume that it is taking 2 bytes. So let us just assume that pointer is taking 2 bytes. So this needs 2 bytes. Now, next point, where the memory for the pointer will be allocated. See, just now in the static memory allocation, I told you that what all the variables you declare in your functions, they will occupy memory inside the stack in their activation record. So yes, for this pointer, memory is allocated here. So this is a pointer. So it takes 2 bytes. So 2 bytes of memory, and this is the activation record for main function. Now I want to allocate memory in heap. So how much memory I want to allocate? I want to create an array of integer of size 5. So this new statement will allocate memory in heap of size 5. So array of size 5. And this pointer will point on this one. Suppose the address of this location, the beginning address is 500. So 500 is stored here. This is the method of allocating memory in heap. So wherever you see new means memory is allocated in heap. Simple variable declaration, memory is allocated inside stack. In C++, it is new. But if I write same thing in C language, then I have to use malloc function or malloc function, and I want 5 integers. So 5 integer, assume integer takes 2 bytes. So this is 2, and I have to typecast it as integer type. So this happens in C++ and this happens in C language. So this is the code for C++, this is the code for C language. Most of the time I'll be using this one, right? This is little lengthy, so I will be writing this one. So that's all. New is used for allocating memory in the heap. Now program cannot directly access that, it has to access pointer. Pointer will give the address of that memory, then the program can reach that location and access these integers. Now, one thing I told you that heap memory should be treated like a resource. After some time in your program, if you don't need that array and you want to make p as null, means you don't want this pointer p to point there, you don't need that memory anymore and you don't want the pointer to point there, so you can make the pointer null. So nothing will be pointing on to this one. Then what about that memory? Is it lost? Is it gone? No, it will not be deallocated. So it's a good practice that when you don't need the memory, you should deallocate it. As you have requested for the allocation, same way you should request deallocation of the memory. So say delete p. You must say delete. As it's an array, so you have to say this one. So when you say delete, this memory will be deleted. And then you can make the pointer as null, so this will become 0. This is not pointing on this location. So that's how heap memory should be explicitly requested and explicitly released or disposed. Otherwise, if you are not releasing it, then the memory will be still belonging to your program and that memory cannot be used again. So it causes loss of memory, and the loss of memory is called as memory leak. And if you continue the same thing in the program for many times, then at one stage the heap memory may be full. There is no free space in heap memory. So whenever you allocate the memory, heap memory, and if you don't need it, release the memory. So let us conclude. We have seen static memory allocation that was done inside the stack for all the variables. Then we have seen heap memory allocation. It is done with the help of pointers, and when not in use, it must be released. So finally we conclude here. We have seen how the static memory allocation is done from the stack and how dynamic memory allocation is done from the heap. So this is the difference between stack and heap. So then in next video, I'll give you introduction to various data structures. In the previous videos already we have studied how a program utilizes the main memory by dividing the memory into sections like a stack and heap. And we have also understood what is static memory allocation and what is dynamic memory allocation. Now let us move to the topic, that is introduction of data structures. In this video, I'll be giving introduction to various data structures. I have categorized them here as physical data structures and logical data structures. So first I'll explain what are physical data structures, just the introduction, then introduction to various logical data structures. Now let us look at physical data structures. These are the two physical data structures, array and linked list. We can have more physical data structure by taking the combination of these, that is array and linked list. We can have some variations in them. Basically these are two. The first thing, why I am calling them as physical. The reason is these data structure decides or defines how the memory is organized, how the memory is allocated. So let us look at them one by one. This is an array. This is directly supported by programming languages, like it is there in C language and C++, and even in Java, this is directly supported. This is a collection of contiguous memory locations. All these locations are side by side. If I have an array for 7 integers, then all these places for 7 integers are together. They are at one place. This array will have fixed size. Once it is created of some size, then that size cannot be increased or decreased. So it is of fixed size. So the size of an array is static. Where this array can be created? An array can be created either inside stack or it can be created inside heap. We can have a pointer pointing to this array. So array can be created either inside stack or inside heap. Anywhere it can be created. When to use this data structure? When you are sure what is the maximum number of elements that you are going to store. If you know the length of the list, then you can go for array. Now second data structure, linked list. This is a complete dynamic data structure, and it is a collection of nodes where each node contains data and linked to next node. The length of this list can grow and reduce dynamically. So it is having variable length. So as per your requirement, you can go on adding more and more nodes and add more elements, or you can reduce the size. This linked list is always created in a heap. Collection of nodes are created always in a heap. Like head may be a pointer that is pointing there, so the head pointer may be inside the stack. So linked list is always created in heap. We go with this one if you know the limit of list or the size of the list, if it is fixed. And we go with this if the size of the list is not known. So these two are physical because they define how the memory should be organized for storing the elements or for storing the data. So these are more related to memory. So I have just introduced these two data structures to you as this is a separate topic in our subject. Now let us move on to the next type of data structures, that is logical data structures. Now let us look at logical data structures. See, here are the list of logical data structures that are stack, queues, trees, graphs and hash table, and these are physical data structure already we have seen. Now let us look at the differences between them. Physical data structures are actually meant for storing the data. They will hold the data, they will actually store the data in the memory. Then when you have the list of values, you may be performing operations like inserting more values or deleting existing values or searching for the values and many more operations. Now the question is how you want to utilize those values. How you will be performing insertion and deletion. What is the discipline that you are going to follow? That discipline is defined by these data structures. That is stack, queues, trees, graphs and hash table. These are linear data structures and these are non-linear, and this may be linear or tabular data structure. Hash table, so it is a tabular data structure. Stack, this works on discipline that is LIFO, last in first out. Queue works on the discipline that is FIFO, and this is a non-linear data structure. This will be organized like a hierarchy, and this is collection of nodes and the links between the nodes. So these data structures are actually used in applications. These data structures are actually used in algorithms. And for implementing these data structures, we either use array or linked list. So this is the important point that we have to learn in this topic. That is, these logical data structures are implemented using any of these physical data structure, either array or linked list or the combination of array and linked list. So that's all. I have given the introduction of various types of data structures. I have categorized them. This was just the introduction to give you awareness. So the conclusion of this topic is I wanted to differentiate type of data structures, that is physical data structures, array and linked list, and these are logical. And these logical data structures are implemented using physical data structures, either using array and linked list. So throughout our course, we will learn about each data structures and we will implement them using array as well as we'll implement them using linked list. So we have to learn this. Here I have given just names of the data structure, some of the data structure. If you pick up each topic, there are a lot of subtopics in them. Like there are different type of queues, there are different type of trees, and there are different type of graphs. So each and everything we learn all those things in detail. So in our course, we will be first learning in detail about this arrays and linked list data structures. We will implement them. We will write the programs for these. Then we'll start learning about these data structure. Every data structure we will implement using array as well as linked list. So in the next video, I'll explain what is ADT and what are the various type of lists. In this video, I'll be discussing about abstract data type, that is ADT. We'll learn what is ADT and that I will explain it through an example, that is list example. So we will learn about list ADT. So first, let us learn the term ADT. ADT means abstract data type. So in this, you leave the term abstract. First, we will learn about data type. What does it mean by data type? So a data type is defined as representation of data, and second thing is operations on data. So a data type is defined in two terms. First is how the data is represented, means how you are storing the data. And second thing is what are the operations that you allow on the data. So if I take an example of a integer data type in C, C++ languages, then if we assume that integer data type takes 2 bytes in C, C++, if I assume that, then once I declare any variable of type integer in C, C++, we get memory of 2 bytes. That is 16 bits. So these are 16 bits. So integer type data is stored in 2 bytes together as a single value, as a single data. Now in this, One bit is reserved as sign bit to allow both positive as well as negative numbers, and rest of the 15 bits are allowed for storing data, that is any number. This is one bit for sign bit, and remaining bits are meant for storing a number. This is how an integer is represented inside the memory in 2 bytes. So this is the representation of integer data type. So as I said, that representation of data and the operations of data. Example of an integer I have taken. So integer, this is how it is represented. So this is the first thing we have covered. And what are the operations allowed on integer type data in C, C++ languages? That is, arithmetic operations are allowed on them. That is addition, subtraction, multiplication, division, and modulus. Apart from this, relational operations, that is less than, greater than, and increment decrement operators are allowed, that is plus plus or minus minus, both pre-increment and post-increment. So these are some of the set of operations that are allowed on integer data. So that's all. This is a data type. So if you talk about a data type, any data type in a language, then that data type will have its representations and the set of operations on the data. So when we are learning any programming language, when we learn any data type, we learn mostly about its operation, and sometimes we go into detail and also understand its representation. Now let us see what is abstract. Abstract means hiding internal details. Now if I take this example, integer data type and these operations. For performing these operations, do we really need to know how they are performed in the binary form inside the main memory? No. We are concerned about declaring a variable and using it by performing these operations. So we need not know internal details how these operations are performed. Right? Without knowing them, we can use them. So these things are hidden from us, so we can call them as abstract. Without knowing internal details, we can use it. So internal details are abstract for us. So this is the example of a primitive data type I have taken and explain you meaning of data type and meaning of abstract data type. This is not abstract data type, this is primitive data type. Now the term abstract data type, why it is introduced, what is the meaning of this one? See, this is related to object-oriented programming languages. When the object-oriented programming languages being started use in software development, then using the classes, we can define our own data types that are abstract. That is, without knowing internal details, we can use them. So this term is related to object-oriented programming. So let us take an example of a list and define it as abstract data type. Let us take the example of a list. That is list of elements or collection of elements. So if I say list of elements, I'll take few numbers randomly. So here I have taken the list of elements. Now I can give the indices either starting from 0 or 1, that depends on my requirement, that depends on my definition. So I'll start indices from 0 onwards. So this is 0, 1, 2 and so on. This is a list, that is collection of elements. Now this is a list, this is on paper. Now I want this list to be used in my program. Then how I can represent a list? So what are the things that I have to store for representing the list? So the data that is required for storing this list is, first I need space for storing elements. Then the second thing is I need to have some capacity of a list. Then the third thing is inside that capacity, how many elements already I have in a list, that is length of a list or size of a list. So the third thing is size of a list. So for representing this list, I need three things: space for storing the elements and its capacity, that is maximum capacity, and its size, that is number of elements it is having. So for representation of this one, I have two options. One is I can use array in a program, or I can use linked list. So representation of a list can be done using any of these representation, any of these methods. Then let us look at operations on a list. What are the operations that we perform on a list? Now for the operations, I will write few operations here. Then again, I will explain all of them. So the operations that I may be performing on the list is, in this set of elements or the list of elements, I can add more elements. So the operations that I can perform is add an element, that is X. Or I may want to remove some element from this one. So remove an element. Or I want to search for any particular element. So let us say it is search. I want to search for any element, key element, like this. So on, so on. I'll be discussing all the operations afterwards. Now let me finish abstract data type here. See, this list is an abstract data type. It is having the representation of data and the operations on the data. So when you have two things, data representations and operations on the data together, it becomes a data type. It becomes a data type. Now this I can put together and I can define a class in C++ or in any other object-oriented programming language. Then the question is how you will be storing this list of elements, either array or linked list. Whatever is used, this is going to work perfectly. I'll be performing these set of operations only. Now how the representation is done, I need not bother about it. I need not bother about. When a class is written, I can just create the object of a class and I can use it. So how internally the things are working, I need not worry. That's what it's abstract. So the concept of abstract data type, define the data and the operations on data together and let it be used as data type by hiding all the internal details. So this concept of abstract data type is very common in C++. So I can say that when you write any class in C++, which has the data representation and operations together, it defines an abstract data type. So in our subject data structure, we are going to learn about various data structures like array, linked list, stack, queues, graphs, trees, hash table. All these things we will try to represent them as abstract data type. So I'll be showing you the code for C language as well as I'll be showing you the code for C++. So I'll be showing you how ADT is implemented. We will be defining all these data structures as abstract data types through C++. So while learning other topics, I'll show you how it is working as ADT. Now next, let us look at these operations on a list. I'll just explain you few operations on a list. What is the meaning of these operations? Now I'll explain you the operations on a list. Let us look at the operations one by one. See, first operation, I will call it as add. Add some element. Adding an element, this makes the meaning that I want to add something to the end of a list. Like suppose I want to add 15. So 15 should be added here at an index 7. So add means adding an element to the end of a list. So this is the meaning that we can take. And even this add can also be called as append. Append an element. I'll write in short for an element. So this also means that adding some element at the end of a list. Now next operation, add an element at a given index. So adding an element at a given index. For example, I want to add 20 at index 6. So here I want to insert 20. So it means already the element 12 is there. Then I should shift the element and make a free space for 20. So it means I should move 15 to the next place on index 8 and I should bring 12 here. Then I should insert 20 here. So if you want to insert any element at a given index, then you have to shift the elements. So that's what adding an element at a given index. Adding an element at a given index. This can also be called as insert. Insert at a given index. I'll write in short, that is INDX for index, this element. adding at a given index, we can also call it as insert. Then next, remove. Removing an element. So which element you want to remove, you must give an index. Suppose I want to remove 20, the one I have inserted just now. So it means this 20 should be removed. When you remove 20, that place will be vacant in a list. So we have to shift the rest of the elements. So 12 should come here and 15 should come here. So I'll be having total 8 elements indexed from 0 to 7. So that's all, removing one element. So rest of the elements are still the part of a list. Removing from given index. Then next operation is set at index a new element. This means changing an element at a given index. Suppose I want to change an element at index 3 to 25. So change this 4 to value 25. So set can also be called as replace, that is replacing an element. Replace at a given index a new element yearly. Then get index. This is just I want to know the element at a given index. Like I want to know what is there at index 5. Index 5, the value is 10. So knowing an element from a given index. Then search for any given key. So searching an element in a list. Like I want to search for an element 9. So yes, it is found here at index 2. The result of search is we get the index. We know the element 9. We want to search for it. So we should know where it is in a list. So it's at index 2. So searching for an element to find its index if it is present in the list. The search is also called as contains key. So we want to know whether this key element is there in the list or not, or the list contains that element or not. Next, you may want to sort the list. So you want to arrange all these elements in some order. That is, you want to make it as a sorted list. So these are the few operations on a list I have shown you. There are other operations also you can perform. That is, you can reverse a list, and when there are more than one list, you can combine them, or you can merge them, or you can split a list. So a lot of other operations you can perform on a list. So as a part of topic, that is ADT, I have taken an example of a list and I have shown you how it is represented and what are the operations. So I have explained you what these operations means. So that's all about ADT. So let us move on to the next topic. Let us talk about time and the space complexity. This is a very important topic, and sometimes it is difficult for the students to understand. Though it is not that difficult, it's not complex. Though the word complexity is used, it's very simple. Let me explain you what does it mean by time complexity. Then afterwards I'll tell you about space complexity also. So first let us start with time complexity. See, in daily life, when we do any work, any task, we want to know how much time it takes for that performing that particular task. Like suppose it is a 1 hour task or 1 day task. So that amount of time required depending on the work that we have to do. So usually in daily life, we measure the time based on the work that we have to do. So now we are using machines to do our work. That is computers to do our work. So we want to know how much time a machine takes for doing the same task. Like if a person is making a bread in 15 minutes, 20 minutes, then if you're using machine for making that bread, how much time that machine takes? We are interested in that one. If machine is taking 4-5 hours, then it's better to do it manually. So how much time a machine takes is very important for us. So we use computers for problem solving. What type of problem solving? The work that we do it using pen and paper. That same work, we want our computers to do that. So computers are used for performing computation tasks. So computation also needs time. So we want to measure how much time a machine will take. So actually that depends on the process or the procedure for completing that task. So the time complexity basically depends on the procedure that you are adopting. So for giving you the idea, I have taken various examples. Using these examples, I'll explain you what procedure may take what amount of time. So let us start with array. See, this is an array of some size and some elements are there. So how many elements are there? See, this is the example already I have taken, and you can count there are total 10 elements. But will it be always 10 elements or depends on the problem? So it depends on the problem. So how many elements may be there? The list of elements in an array, we say n elements. We don't know how many elements will be there. Maybe 10 or 10,000 or 10 million. We don't know. So we say n. N means some number of elements. That number of elements may start from 1 up to infinity. So we don't define infinity. So up to maximum number. Whatever the number you can imagine, you take that one. So n means not just 5 or 10. This is the first important thing. Mostly students get confused here. So n means some number of elements. So let us say there are n elements in this list. Now, what you want to do with these elements? I want to add all of them. So you have to go through all of them. Yes, one by one you have to take the element and go on adding it. So how much time it takes depends on the number of elements. So what is the time taken? N. We say n. The next thing, what do you want to do? I want to search for a particular number, whether element 12 is there or not. Search for it. Yes, it is there. I want to search for an element 21. Is it there or not? Check for all. No, 21 is not there. So at most, how much time it is taking? It depends on the number of elements that you have to compare. So how many elements are there? N elements are there. So what is the time taken? N. So the time is n. So it means in a list, if you have some n elements and you are going through all of them just once, then the time is n. So this n we represent it as a degree. So we can say order of n. We usually use the term order. Degree or order are same thing. So we use the term order of n. There are other terms like big O, omega, theta, that I will explain you at the end of the course, because till then you will be having the good understanding of time complexities. Then I can explain you what is big O, omega and theta. So throughout the course I'll be using term order of. So when we know what are asymptotic notations like big O, omega, theta, then you will understand how to use them. So let us say order of n. Then next very important thing. If you want to access that all the elements, then what the code that you have to write? For I assigned 0, I is less than n, I plus plus, then whatever you want to do here, means you want to add all of them or search something or count number of elements or finding maximum element, whatever you want to do, that logic come here. So that procedure comes here. So whatever the procedure may be, then this for loop will taking us through all those elements one. So how many elements? N elements. So what is the time out of n? Now listen, the very important thing. For finding the time complexity, either you can measure the time based on the work that you are doing, means what is your procedure. If you are clear with your procedure, you can know the time, or else from the code, program code also you can find the time complexity. If there is a for loop, going through 0 to last element means it's n. It's taking order of n time. Whatever is there inside will repeat for n times. So we analyze based on the procedure also, based on the code also. And the most confusing thing is when the code is given, we get confused how to analyze this one. So actually what the code is doing, you do that work and based on the work you analyze it. It's very simple. It's very simple. If you don't want to understand what the code is doing, then it's a difficult task. So if for loop is used means there is a chance that time is order of n. Now let us move to the next situation. See, in this list, suppose being on the first element, I am comparing or processing all other elements once. Then being on the second element, again I am processing all other elements. Maybe I am comparing for sorting purpose, whatever the purpose may be. This 5 I am comparing or processing with rest of all the elements. Like that, for each element I'll be checking with all the rest of the elements. So for one value it will check for all, means n elements. Then for the next value also, if it is checking for all, processing for all, then n elements. So n elements are being processed. But how many times? For each element, n elements are processed. So this will be n square. This is n into n, that is n square. So we can say order of n square. So this is another case. Now in this same case, I'll show you one more thing. For processing like this, how the code should look like. The code should have nested for loop. Again, I should have for loop, that is for j assigned 0, j is less than n, and j plus plus. And inside this, I'll be writing that processing. Whatever the work I want to do, these will be the statements. So when you have two nested for loops, it's n square. Simple. You don't have to check line by line every statement and all. Just from the code you got the rough idea. You can say it's n square. But sometime for analyzing the code, we check every line. So the idea is we should not miss any line. We should read it, check it thoroughly. That's why we write the time complexity. But overall, the time complexity is written in terms of a degree of a polynomial. So it is order of n square. Nested for loop means n square. So let us follow it like a formula. Third situation for the same array. See, suppose being on first element, I am processing rest of the elements. So n minus 1 elements I am processing. Then being on the second element, I am processing rest of the element. I am not processing upon this one, right? So n minus 2. Then being on the third element, I am processing rest of them. It depends what you are doing, right? So imagine something you are doing. So you are processing rest of the elements. So this is n minus 3. Like that, it will be go on reducing. Then finally it will be 4 element, 3 element, 2 element, then 1. This is what? N into n minus 1 by 2. Sum of first n natural numbers. So this is not n minus 1. So this will be n square minus n by 2. So what is the degree of this polynomial? This is n square. So it's order of n square. So that's what the time complexity that we are writing the degree of a polynomial. See, this time I have done detailed analysis and I got a polynomial, and for that I got a function. That's like a function, and the degree of a function is n square. So time is n square. If same thing I write it in the form of a for loop, then this j will not be starting from 0, but j will be starting from I plus 1. See, now again two nested for loop. So at most this will take n square time. Yes. Then next I'll show you one more situation. Fourth one. Let us look at this. I'll remove this one. Now in this array, suppose first of all we are processing the middle element. Suppose 4 is the middle element, right? There are total 10 elements. So fifth element, let us say middle element. Then next, either on the left side or on the right side, again we go on the middle. Suppose this is the middle element on this side. Then again middle element on this side. So in this way, we are not processing the entire list. We are processing half of the list. Then again it's half. Then again it's half. So that process is always dividing the list by 2. So when something is successively divided until it reaches 1, that is represented as log. And we are dividing it by 2, half. So log of n elements. Log n. So the time complexity is log n. If we are not processing all the elements. Then if I write a code for that one, then the code may look like this. For I starts from n. And I is greater than 1. I is getting divided by 2 every time. That's it. Now, just by looking at for loop, don't tell blindly order of n, because just now previously we saw order of n. Read it, how the for loop is behaving. That's why we check it thoroughly. When we are reading the code, we thoroughly check line by line, so that we should not go wrong. But overall, we need answer log n. If the value of counter I is getting divided by 2 every time, then it is log n divided by 2, log n base 2. And how long it is happening? Until it reaches 1. The same thing can even be written using while loop. See, I assign n, and while I is greater than 1, and some processing, I is always divided by 2. Same thing. Instead of for loop, you can use while loop also. Usually, when this is not incrementing 1 by 1 every time, for loop is not incrementing by 1 every time, we prefer using while loop. But in C, C++, Java programming, when for loops are there, people use for loop for this purpose also. For loop is used for counters which are incrementing by 1. So anyway, when this is written, you have to read it thoroughly and find out how much time it is taking. So we have seen 4 different behaviors of procedures that are performed on array, and also I have shown you the code and also shown you how we can analyze from the code, how we can analyze from the work. So if you are analyzing from the work, the process, that's more better. Now let us proceed ahead. See, this is a linked list. We'll be studying about this linked list data structure later on. This will be same as array. Like this is list and this is also a list. So what all we studied there, same thing applies here. The next is a matrix. Matrix is having how many elements? The dimensions are 4 by 4. So total how many elements? If dimension is n cross n, then total n square elements. So when you are processing upon a matrix, then it will require n square amount of time if you are processing all the elements. If you say no, I am just processing a row, then row is having n elements, order of n. No, I am processing just a column, so again it's n, order of n. If you are processing all elements, then it is n square. Now I'll show the code for that. I'll remove this. For processing a matrix of elements, we need 2 nested for loops. I++, and inside this for j assign 0, j is less than n, and j++. Now whatever you want to do with those elements, you can do that. So this is n square. Now for one element, if you're processing more upon that element and that requires suppose a loop, or suppose you are calling a function which is having a loop, then the time will be more. For 3 for loops inside, then it will be n cube, right? If you are processing only 1 unit of time, just 1 statement or 2 statements are there, simple statement, no loops, then it's n square only. Then coming to this structure. This looks like array of a linked list, like linked list, right? So total how many elements are there? So here let us say n elements are there, these elements. So you can see that these are of different sizes. And here array of size m. So total how much processing you require? We have to process all these n elements as well as using this array. So we can say m plus n processing is required. If you say no, I don't want to consider this, I want to consider only the number of elements, okay, consider only n number of elements, order of n. What does it mean by considering, not considering? I'll give you the idea. Just listen as an example. Suppose you are giving a party to your friend. Some 4 or 5 friends, you have called them on a hotel for a party. Then what is the cost? The cost of the food that you are taking there. Then the bill at hotel plus traveling amount, and if any extra other things that you are spending on, tips you are giving, do you consider that amount also and include it as the cost for a party? It depends on you. It depends on you. The same way, whether you want to analyze or not, it depends on you. So you should be in a situation to understand whether you need it or not. Right? Mostly what students believe that they are doing it because it is given as a task, as a challenge. So somebody's else job they are doing. So they get worried whether I should consider or not, why I should leave it. So that is your choice. You be in that situation and solve it. So that's all. If you say I don't want to consider this, means you are processing it, but you don't want to consider the time taken for that one. So only order of n. That's it. So this structure is over. Now last one, this one. This is a binary tree. So if you have a binary tree structure, total elements are 1, 2, 3, 4, 5, 6, 7. 7 elements are there. Then how much processing is done? Suppose you are processing, searching or something, and you are processing upon the elements only along the path, like this one, then this one, or this one, or this one, then this one, and this one. Suppose you are processing just along a path, then what is the height? It depends on the height. So how many elements you are processing? See, there are some elements divided by 2, then divided by 2 until it reaches 1 element. So total 7 elements are there. As from the bottom, if you see, the number of elements are divided by 2, then divided by 2. So it looks like log n. Yes, log n base 2. So we'll be studying about this one. So if you are spending time upon a tree along the height of a tree, then it is log n. Next situation. If you say no, I want to process all the elements, then how many elements are there? N elements. So it is order of n. Then whatever the program code that you write for processing this one, that code also will be order of n only if you analyze that one. So this is the general idea I have given you about the time complexity. So the time complexity is sole and sole dependent on the work that you are doing. Now a little bit on space complexity. We want to know how much space is consumed in main memory during the execution of a program. So array, n elements are there, so it's order of n. This is n elements are there, order of n. Space is n, means n integers or n floats or n doubles, whatever it is, n elements we say. We are not concerned about the number of bytes, right? We are not concerned about that. We are not calculating that. We want to know the space is dependent on what? N. If the value of n is more, the space will be more. That's what the idea is. Then here also it's n. But along with the element, you need space for links also. So let us say 2n. 2n again, the degree is what? Order of n. Then coming to this is space is n square. And this is place is m plus n. And the space here is n nodes are there. So it's n, order of n. So the next video, I'll take few program code and show you. So without looking at the processing, just from the program code, how to find out the time complexity, I will show you. So that's all in this video. Now let us learn how to find out the time complexity from the program code. So when we analyze the program code, we get a proper function, time function. So how to get the time functions, we will learn about this. So for explaining, I have taken 3 example program codes. That is 3 functions I have taken. Now how to analyze? We assume that every simple statement in a function or a program takes 1 unit of time. What does it mean by simple statement? The statement may be having arithmetic operations, assignment or conditional statement. If it is more complex, then we have to study that also in detail. So let us see how to get the time function and how to find the time complexity. So first I will take this one. This is swap function taking 2 parameters and interchanging the values of x and y. What are the statements inside this? These are the 3 statements. How much time each statement takes? 1 unit of time, because it is just an assignment. So total time is 3. So the function of n is 3. So we got the time function as 3. So that 3 is constant, order of 1. Why it is constant? Because the degree of n is 0 here. 3 means 3 into n to the power of 0. That is the meaning. So anything power of 0 is written as what? 1. So it is constant. So this was a simple function and it is taking constants. So it's not a proper C function. I have not written data types and all. Just a pseudocode I have written. Now this is exactly like a C functions. Let us look at this one. Now here, let us look at the statement. First statement, assignment, 1 unit of time. Then assignment, condition, assignment. This is plus plus, increment, just an operator. But is it executed just one time? No, this is a loop. These statement will execute for n times. See, if you know for loop, this will execute for one time, initial. And this increment will happen for n times. Condition also n times, but one time the condition will fail, so it will stop. So this is total n plus 1. So we can ignore all other and take just n plus 1. So just for loop, we are looking at this one, just for loop is n plus 1. Let us say time taken is n plus 1. Then you can ask me why you are leaving this one and this one. Okay, if you want to include, then it should be 2n plus 1. That's your choice. But mostly we find like this in textbooks, every author says this one. But mostly we focus on this conditional statement, so I am writing the conditional statement. Otherwise, if you sum up all these, this is 2 times of n plus 1. Then next, what is there inside? This is a statement. It's a simple assignment and arithmetic operation addition. How many times? As long as loop is running. How many times loop will run? N times. This is n. Then at last, return s. How many times this will execute? Just one time. So total how much? I'll find the sum of all these. 2 times n. So the time function is 2n plus 1, 2, 3. 2n plus 3. This is the time function we got. And what is the degree of this polynomial? This is order of n, degree 1. So we write n. So the time is order of n. Now already in the previous video I have shown you that when you have a for loop which is repeating for n times going from 0 to n and I plus plus every time, it's obviously n. So even when I have check each and every line also, final answer is order of n. That's what. If you focus on the processing, then you can directly get the answer, this one. If you are interested in this function, then you can get it. Line by line you analyze and get it. So let us see the procedure actually. This is sum of all n elements in an array. Sum of all n elements in an array. How much time it will take? It depends on number of elements. How many elements are there? N elements. Time is how much? Order of n. Simple. Now while doing line by line, it needs little practice. Okay, so I have shown you 2 examples. So based on this you can practice and find out the time from the code also. Now the last one remaining is this one. Let us find out the time. So I'll remove that one. Now this one, this is a for loop. As I said, this will take n plus 1 times. So n plus 1 times the execution will happen. Now anything inside the loop will execute for n times, every statement. So what is there inside this loop? This one is there, this one and this one. So I have finished with outer loop. Outer loop is over. Now inside that, this is not a normal simple statement. Just like this normal simple statement, I have taken n. For this also I have taken n. But if you look at this, this is also a loop. Then what about its time? The time for this one is, how many times the condition is checked? N plus 1. So this is already n because it is inside this outer loop. So shall I write plus n plus 1 or into n plus 1? Nested loop is there. Nested loop is there, right? So it should be into. It should be into multiplication. So this is into n plus 1. Then this statement is inside this for loop also. So this loop will repeat it for n more times. So this is into n. So that's it. So if you want, you can watch it again and find out how to do this one, right? Now finally we can prepare a function, time function. What is the time function? N square, so 2n square plus n, 2n plus 1. This is the time function we got. What is the degree? 2, so it's order of n square. Time is order of n square. This is how from the time function we get the highest degree of a function, and that we represent it as time. Now I am calling it as order of, if you are interested you can say big O of n square or theta of n square and omega of n square. But when to use these we will be learning at the end of the course, as I said. But by that time you can even call order of, or even you can use big O. Instead of order you can say big O, right? But in my videos I'll be calling it as order of every time. And at last I'll show you one more example. I'll remove these things and I'll write one small example program, then I'll explain you. So here is an example. I have just taken a skeleton of 2 functions, function 1 and function 2. Now if you want to find out the time complexity, as I said, every statement we should consider it as 1 unit of time. So how much time this function is taking? I want the time taken by this function only, fun1 only, right? Then what is there inside? Just one line, 1 unit of time. So it's constant. Wrong. That's a function. How much time that function is taking, you find out that one. Don't say that statement is 1. Okay, look at this one. This is having a loop. So loop will take order of n time. So it's n. So the time taken by this function is not 1, it is actually n. So in turn, the time taken by this function is also n. It's not 1. It's not 1 because it is calling a function which is taking order of n time. So definitely that time will be spent by this fun1 only. So definitely that time also belongs to fun1 because fun1 is using fun2 and fun2 is taking order of n time. So that's how. Look into the details of these statements and try to find out the time. If there are simple statements, you can directly write down the time as 1. If it is complex, then see what it is doing, then based on that you can write down the time. So mostly loops are making the time as n or n square or maybe n cube. So mostly it depends on loops that you are using. While loop, for loop or while loop, they both are similar. Sometimes students think that for loop, okay, I understood. While loop, how to do that? So for loop, if it is repeating from 1 to n, an incremental loop, counter control loop, then it is n. If it is behaving in a different way, then definitely you have to read the code and understand. Maybe it is log n or a root n, what it is. You have to find out that. So that's all in this video. We have seen the time functions. Space complexity already I have explained you in the previous video. So space complexity also we can prepare a function. So that's all in this video.